In this video, we're going to go into a little more detail on circles. In particular, we're going to cover inscribed angles and shapes, outside angles, and Ward's theorem. In a circle, an inscribed angle is formed by two chords that share a common endpoint. If we look in the circle in the top left, we can identify several inscribed angles. Angle ABF, angle ABE, angle ABD, angle FBE, angle FBD, those are all inscribed angles. The arc made by the inscribed angle is called an intercepted arc. So for example, if we're looking at angle ABF, the intercepted arc is going to be arc AF. The measure of an intercepted arc is twice that of the measure of the inscribed angle. For example, let's look at angle FBD, which is marked by the dotted blue lines. Angle FBD is equal to 1/2 the measure of arc FED. Likewise, for angle ABE, that is equal to 1/2 the measure of arc AFE. In a circle, an inscribed shape is one which has all its vertices on the circle. If a square is inscribed in a circle, its diagonals will form a diameter. So if we're looking at the square AECB, we can see that the diagonal BE is actually a diameter as it passes through point G, which is the center of the circle. An inscribed triangle having a side passing through the circle center is always going to be a right triangle. Now that we've gone over some of those points, let's do a couple of practice problems. For the first problem, we're going to use the circle on the left. A triangle is formed by connecting points E and D. If angle DEB is equal to 55 degrees, what is the measure of arc ED? So what we have here, let's connect points E and D. So I'm going to draw that in roughly in red. So now we have triangle BED. We know that because the side BE passes through the center point G, we know that this has to be a right triangle. So let's draw in a right triangle here at angle BDE. We also know that angle DEB is 55 degrees. So we'll draw that in. From that, we can figure out that angle EBD has to be equal to 180 minus 90 minus 55, or 35 degrees, because the three angles in a triangle have to be 180 degrees. Knowing that angle EBD is 35 degrees, we can figure out the measure of arc ED by noting that the measure of an intercepted arc is twice that of the measure of the inscribed angle. So we have 2 times angle EBD is equal to the measure of arc ED. So the measure of arc ED must be 70 degrees. A square with a side length of 4 is inscribed in a circle. What is the area of the circle? So we know that an area of a circle is equal to pi r squared. We have a square with a side length of 4 inscribed in a circle. That means the diagonal of the square passes through the center of the circle. That means we know that the diagonal of the square forms a diameter for the circle. We can calculate the length of the diagonal with the Pythagorean theorem, or by noting that the diagonal ends up turning this into two 45, 45, 90 right triangles. That would make the length of the diameter equal to 4 times the square root of 2. If the diameter is 4 root 2, then the radius has to be half of that, so the radius is equal to 2 times the square root of 2. Now that we have the radius, we can plug it in for the formula for the area of a circle. So then we get the area of the circle is equal to pi times 2 square root of 2 squared. That, of course, is going to equal 8 pi. Let's move on to outside angles and Ward's theorem. A line tangent to a circle shares one point in common with the circle. So in the figure we have two tangent lines, line AE and line AB. Line AE shares a point Z with the circle, and line AB shares a point W on the circle. A radius sharing a point with a tangent will form a right angle with the tangent. So we can see that drawn in there next to point Z. A secant line intersects a circle at 2 points. So we have two secant lines, line AD and line AC. They are denoted with blue dotted lines in the figure. A two tangent or secant combination, so that means if you have two tangent lines, two secant lines, or a combination of a tangent and a secant line, if they intersect outside a circle, that forms something that is called an outside angle. And an outside angle is equal to 1/2 the difference of the measure of its intercepted arcs. Let's do an example to kind of clarify that. Angle EAD is equal to the measure of arc UZ minus the measure of arc YZ over 2. If we look at the figure, we can see angle EAD has two intercepted arcs. The larger arc is arc ZU, or UZ, and the smaller intercepted arc is arc YZ, or ZY. When you subtract the bigger arc and the smaller arc and divide that by 2, you get the angle EAD. That example is when we use a tangent line and a secant line. If we use two secant lines, we can use the same formula. So let's look at angle DAC, which is formed by the two secant lines DA and CA. Angle DAC is equal to the measure of arc UB minus the measure of arc YX over 2. Again, you're taking the larger intercepted arc, arc UV, and you're subtracting the smaller intercepted arc, arc YX, and you're dividing that by 2 to find the measure of angle DAC. The third case is when you have the outside angle of two tangent lines. While we can use the equation that we used for the previous two examples, we can actually use something simpler called Ward's theorem, which states that the outside angle of two tangents plus their smaller intercepted arc is 180 degrees. For example, if we take angle EAB, which is made up of the two tangent lines EA and BA, and if we add to that the measure of arc ZYW, which is the smaller intercepted arc of that angle, we get 180 degrees. So let's do a couple of problems using that circle on the bottom left. If angle DAX is equal to 15 degrees, and the measure of arc YX equals 20 degrees, what is the measure of arc UV? So angle DAX looks like it's formed by two secant lines. It's actually the two blue dotted secant lines. So that is 15 degrees. And we are given the measure of YX, which is the smaller of the intercepted arcs. So we can write out that angle DAX is equal to the measure of arc UV minus the measure of arc YX all over 2. Then we want to isolate the measure of arc UV. So we'll get 2 times angle DAX plus the measure of arc YX equals the measure of arc UV. When we plug in our numbers, we get 2 times 15 degrees plus 20 degrees is equal to 50 degrees, which is equal to the measure of arc UV. If the measure of arc ZVW equals 285 degrees, what is angle ZAW? This is a classic Ward's theorem problem. So we're given the measure of the greater arc, ZVW, but we don't need the greater arc, we need the smaller intercepted arc, because the smaller intercepted arc and the outside angle that is formed by two tangents is equal to 180 degrees. But when we have two tangent lines, we should recognize that the greater arc and the smaller arc add up to 360 degrees, because that is the entire circle. So that gives us the measure of arc ZYW is equal to 360 degrees minus the measure of arc ZVW, which is equal to 360 degrees minus 285 degrees, which is equal to 75 degrees. Now we know that the measure of arc ZYW, which is the smaller intercepted arc, plus angle ZAW equals 180 degrees. So we can substitute in our value of 75 degrees to figure out that angle ZAW is equal to 105 degrees.